This is the deep learning specialization course from basic to advanced. So let's jump into our course. So at first we will see that what is deep learning. So the definition of deep learning is that it is the branch of machine learning that is based on the artificial neural network architecture. An artificial neural network, or ANN, uses layers of interconnected nodes called neurons that work together to process and learn from input data. And what is ANN? Artificial neural network, or ANN, is a type of neural network that is based on feed-forward strategy. It is called this because they pass information through the nodes continuously till it reaches the output node. This is also known as the simplest type of neural network. And what is the single layer perceptron? It is one of the oldest and first produced neural networks. It was produced by Frank Rosenfeld in 1958. So perceptron is also known as artificial neural network. Perceptron is mainly used to compute the logical gate like AND or and NOR, which is binary input and binary output. So the main functionality of the perceptron is takes input from take input from the input layer, weight them up and sum it up, and pass the sum to the nonlinear function to produce the output. Their activation functions can be anything like sigmoid, tanh value based on the requirement. We will be choosing the most appropriate nonlinear activation function to produce the better result. And here we see some of the implementation of the single layer perceptron, or ANN. So here you see the we import basically the libraries like NumPy and TensorFlow. Basically, the this line import TensorFlow as TF. This line basically imports the core TensorFlow library, a powerful framework for building and training deep learning models. TensorFlow does the heavy lifting of the calculations behind the scenes. And it's the second line from TensorFlow import Keras. So this is the line imports the Keras API, a high-level interface built on top of TensorFlow that makes deep learning code easier to write and understand. Use Keras to define our model. And uh, and the and the next line, checking dataset sizes. These lines likely refer to preloaded variables containing your training and testing datasets, and these variables probably hold images, and these lines simply count how many images are in each set, and that means training and testing basically. And exploring the image data. So this line of code basically shows the shape of the first image in the training set. And in image recognition, this is typically a 3D array representing height, width, and color channels. Uh, Basically, the RGB channels here. And we visualize the image by plot plt, I mean dot matso. This line uses the matplotlib to display the first image from the training set as a grayscale heat map. This can help you get a sense of what the data looks like. And after that, we normalize the data by xtrend equal to xtrend by 255 and xtest equal to xtest by 255. And basically this line demonstrates that the this lines divides each value in the training and testing sets by 255. And this is a common normalization step in image processing. Images typically have pixel values between 0 and 255, and normalizing them to a range of 0 to 1 can improve the training process for some deep learning models. And after that, flattening the data by this line. And originally the images are likely stored in 3D arrays. These lines of reset them into 2D arrays by multiplying the height and width. This flattens the data into a single list of values for each image, which is more suitable format for building the deep learning model. And after that, at last we building the deep learning model by this line model equal to keras dot sequential. This line creates a sequential model, which is a commonly way to stack layers in keras. Layers are building blocks of neural network, and uh, here we use the activation function sigmoid, and and at last we configuring the model. Basically, these sets of the optimization algorithm. Adam is a basically a popular choice, that will adjust the weights of the neurons and in the model during training to improve the performance. And loss equal to this line, loss equal to spare sparse categorical. This line defines the loss function that is suitable for multi-class classification problems, that the model. So this is for now, and I hope you guys are understand this. So thank you guys.